So instead of using formulas and combinations to calculate binomial probabilities, we're going to use Stapplet. Stapplet is going to give us a lot of information, let us plug in things more easily, and then with that, we just need to know how to interpret the results. So at the top here, I have some definitions for us that come with working with a binomial probability model for these Bernoulli trials. So one piece that will be helpful is how we define our random variable x. So remember that capital X is a random variable where we're looking for some probability of events that occur for x. Then if we know we're working with Bernoulli trials, then what we would say is x is defined by a binomial distribution with some value for n and some value for p. So that tilde symbol there, the little squiggle, that's read as is defined by. And we're going to see this come up one more time when we work with normal models. We'll kind of use this notation too. So we say x is defined by, and then we know we have a binomial model, and then we describe the value for n and the value for p, where n is our number of trials and p is our probability of success. So if we have that information, binomial n and p, we can set up the entire distribution of probabilities and start calculating with Stapplet from there. Okay, some other notation. We'll see, not so much with the calculation. It's part of the formula, but there's also Q, which is just 1 minus our probability of success. So those two numbers should complement each other. They should always add up to 1. And then our random variable x, what it is representing is the number of successes out of n trials. So we're looking for the probability of 5 successes, 10 successes out of a certain number of trials. Mean and standard deviation, or expected value and standard deviation, either way, those are interchangeable. We can calculate this by taking n times p. We'll calculate our expected value. Standard deviation will be the square root of n times p times q. So really straightforward calculations, especially after our discrete random variables. These should take all of 1 or 2 seconds to plug in the calculator, get a number out. Much more straightforward. Even then, when we get into Stapplet, when we plug in our value for n and value for p, it's automatically going to give us expected value and standard deviation. So we don't need to do the calculation, but the formulas really aren't too bad. So when we get to a question working with those, I'll show both ways. Okay, so let's talk about going to Stapplet and what it will tell us, and then also we'll go through an example with our free thrower making 82% of her baskets, and she's going to shoot 10 free throws. Okay, so if we go to stapplet.com, what we'll do is go down to probability, where we'll find binomial distributions. And they'll be blank, and all it wants to know is what is n and what is p. So the example that we're going to look at, it said she's making 82% of her free throws, and she's going to shoot 10 free throws. So 10 would be our number of trials, and then her probability of making a free throw is 82%, which we'll type in as a 0.82. And then we'll plot our distribution. And this visual right here, it shows a lot of information with our probabilities. We can see this would be the idea of getting 0 of the 10 free throws, 1 of the 10, 2 of the 10. So you can see those probabilities are 0 there. At 3, we start to see a little tiny sliver, so 0.04% chance. And just to keep in mind, like, her probability of success is 82%. So we expect her to make a lot of her free throws. So that's where it makes sense that we're seeing these probabilities having a higher value higher up in the number line, closer to 10, because she's so good at throwing free throws. So with this, hovering my mouse over, we could see the individual probabilities, like the probability that she would make exactly 7 of the 10 free throws is 17.45%. So without plugging anything in, we get those kind of exact probabilities. Then down below, we can find our mean and standard deviation. And then down here, we can start plugging in values to find different scenarios of what's the probability she makes more than 2, less than 9, at least 7, at most 5, things like that. So where you see calculate the probability of and then exactly has a drop-down option, and we're going to be able to match our wording to the scenario that we're looking for. Okay, so with that, let me just make sure I talked about all the pieces here. So we go to binomial distribution, plug in n, plug in p, and then that will give us all our information there. The graph shows the heights, and we can get exact probabilities from that. We also get our mean and standard deviation, drop-down menu. Oh, and then we can also find probabilities between two values. Okay, with that, let's go to our example. So again, with this case, so our free throw is making 82% of her baskets, and she's shooting 10 free throws. So when I go and look at kind of the questions, what's the probability that she makes exactly 5 free throws? So we're looking for her to make the free throws. So that tells me that this 82% is my probability of success, probability of matching with the idea of her making a free throw. And then she's going to shoot 10 free throws. So that's going to be our number of trials. So if I wanted to define this distribution, so X would represent the number of free throws she makes. So it'd be like the number of successes. And then our distribution says this number of free throws that she makes is defined by a binomial distribution. And we know it's binomial because she either makes it or she doesn't. And we're looking at a strict number of free throws. So we have this set number of trials and there's only success, failure. All right, binomial. And then I would say that n is 10, comma, 0.82. So that notation there, X is defined by binomial 10.82, defines our entire model. And that's what Stapplet's using to kind of distribute all the probabilities. Okay, some formatting here that we are going to use as we work through examples together, as well as with your participation and written assignment and work like that. So for each probability, we're going to include the correct probability notation and a complete sentence answer. So I'll show examples with this, and then you can match that up as you work on your assignments for the week. So what is the probability that she makes exactly 5 free throws? So my probability notation would be P of X equals 5. And then from there, there's actually 2 ways to find this. I could either go to 5 on the graph and hover my mouse over it. So I see P of X equals 5 equals 1.77%. Or down here, we could do calculate the probability of exactly 5, and that'll give the same answer up. So it's saying 1.77%, and I'll go ahead and write that down there. That's perfectly fine. Just to make sure, because my open math often wants probabilities in a decimal form. So this would be the equivalent of 0.0177. So as we go through these, I'll also write the decimal form so you can kind of keep seeing the translation between percentage and decimal so you know how to plug it into my open math. Okay, there is a 1.77% chance she makes 5 of the 10 free throws. Okay. What's the probability that she makes 9 or 10 free throws? So there's a few ways we could write that. Let's go with P of X equals 9 or 10. We'll just do that for our probability notation. What this is going to come down to is adding 2 probabilities together. P of X equals 9 plus P of X equals 10. And with that, we'll grab our values from Stapplet. So for 9, that's a 30.17%. And we want to add on the probability for 10, which is a 13.74%. And that's going to come out to a 43.91%, or if you need the decimal form, 0.4391. So there is a 43.91% chance she makes 9 or 10 of the free throws. All right. What is the probability that she makes at most 2 free throws? So you could jump into writing down your probability notation here. I will let you know that Stapplet's going to show you the probability notation when you put your answer in. My recommendation here is try to write it for yourself first, because that could possibly catch an error as you work between Stapplet, just in case the probability goes in the wrong direction. So we want at most 2. So I want 2 to be the largest thing. So I want the probability of x, and x is going to be less than or equal to 2. So that's the notation that I would interpret from the wording of the problem. So what I'm going to do is then go to Stapplet, calculate the probability of, and I'm going to use the drop-down menu to find at most. I'm going to plug in 2, go, and I'm seeing 0%. And something to notice is up above on the graph distribution, it is going to be shading the area that you're looking for. So what I can do is keep in mind that, okay, I was thinking 2 is the largest, and I want everything below. So this image is matching what I was thinking. And then also my notation is matching here as well. So we're getting out a 0% chance. There is a 0% chance that she makes at most 2 of the 10 free throws. She's just so good at it, it's almost impossible for her to do poorly. All right, what's the probability that she makes at least 7? So 7 should be our smallest number. So we want to see the probability that x is more than or equal to 7. So with that, we'll go here. We're going to go at least, and then 7, go. And we're seeing 91.17%, and we can see that highlighted region that we're starting at 7 and going up above. So it's just nice to have that visual matching up with the calculation piece. So that is a 91.17%, or a 0.9117 if you need the decimal. There is a 91.17% chance she makes at least 7 of the free throws. Okay, so I'm going a little faster so that it's not a terribly long video. What's the probability that she makes between 6 and 8 free throws? We're going to assume this is inclusive. So we're going to assume that 6 and 8 is part of this group. So I want to find the probability of between 6 and 8. So in Stapplet, what we're going to do is go down to the second line for calculate the probability of between 6 and 8. And notice it says inclusive there, so that just means it's including 6 and 8. If it was exclusive, then all that would be showing up is the probability for 7. And we are getting a 53.95%. Or a 0.5395. So there is a 53.95% chance she makes between 6 and 8 free throws. Okay, not last piece, almost last piece. What's the expected number of baskets and standard deviation? So I wanted to show how to do this by hand. So the mean comes from n times p, which is 10 times 0.82 in this case, which would be an 8.2. And standard deviation comes from the square root of n times p times q, which would be the square root of 10 times 0.82 times 1 minus 0.82, which is a 0.18. And then we would put that in a calculator and we should get out a 1.2149. So that's how we would calculate it by hand, but just notice it also is provided right there in Stapplet. So either way, just grabbing from Stapplet to get those exact values is fine, or you can go through that calculation. So this would mean out of 10 free throws, we expect her to make about 8, which on average will deviate by about 1 free throw. So we expect her to make about 8, but it will deviate using that standard deviation. I rounded to 1. Okay, something we're going to do, which in this case is kind of repetitive because it's on the previous page, but I want to see what you have plugged in to Stapplet. So you're going to be taking a screenshot and attaching it to your work. So what we would do is, and it's just what I have here on this page, and in fact, you can even cut it off here, including the mean and standard deviation might be nice. But including a screenshot of this so I can see the setup, I can see what the outputs are, so I can see what you're working with in Stapplet, so that if all the numbers are wrong, this will give me a sense of what happened. Did a decimal place move? Was one of the numbers typed in incorrectly? Something like that. So you'll be grabbing a screenshot. The resources for taking a screenshot you can find in course information module under other resources, where I have the steps for taking screenshots across different computers.